Imagine a world where the continents looked nothing like they do today. What if the land beneath your feet was once part of a colossal supercontinent that housed unimaginable biodiversity? Get ready to journey back millions of years and uncover the mind-bending tales of Earth's ancient, lost land masses that shape the very planet we inhabit. Have you ever looked at a map and wondered about the incredible forces that shaped our continents? The familiar shapes we know today are just the latest chapter in a cyclical dance of colossal land masses forming and breaking apart. This isn't science fiction, it's Earth's ancient past, a story written in rock, fossils, and the very fabric of our world. This epic story is driven by a powerful engine deep within our planet, plate tectonics. The Earth's crust is broken into massive plates that are constantly in motion, floating on the semi-molten mantle beneath. Over immense stretches of time, these plates collide to form supercontinents, and then, inevitably, they rip apart again. It's a slow, powerful ballet that has repeated itself for billions of years. Each cycle dramatically reshaping the face of our planet, altering climates, and steering the course of evolution. So, let's peel back the layers of time and meet some of these forgotten giants, starting with the southern behemoth, Gondwana. Long before the world map looked anything like it does today, much of the southern hemisphere was a single, sprawling landmass. This was Gondwana. It formed around 600 million years ago and was a true cradle of life. Imagine a world where what we now call South America, Africa, Antarctica, Australia, the Indian subcontinent, and the Arabian Peninsula were all connected. The evidence for this is overwhelming. Geologists have found matching rock formations and mountain ranges across these now separated continents. Paleontologists have unearthed identical fossil species of plants and animals, like the famous Glossopteris fern and the Lystrosaurus reptile, in places now separated by thousands of miles of ocean. These creatures couldn't have swum across vast seas, proving they once lived together on the same land. Gondwana's existence wasn't just a geological curiosity, it fundamentally shaped the planet. As this giant began to break apart around 180 million years ago, it was a world-changing event. New oceans, like the South Atlantic, were born. This fragmentation completely rerouted ocean currents, which are like the planet's circulatory system for heat. The new patterns of water circulation led to dramatic shifts in global climate, creating new environments and challenging life to adapt or perish. The breakup isolated populations of animals, setting them on unique evolutionary paths that led to the distinct wildlife we see today in places like Australia and South America. The story of Gondwana shows us how the dance of continents is directly linked to the story of life itself. But Gondwana wasn't the first. To find Earth's earliest supercontinent, we have to travel much, much further back in time. Now, let's journey back over 1 billion years, to a time so ancient, it's hard to even comprehend. We're looking for Rodinia, a supercontinent that existed long before the dinosaurs, long before the first fish, and even before the first complex animals appeared. Reconstructing Rodinia is an immense geological detective story. The rocks from that era have been squeezed, melted, eroded, and recycled by Earth's processes for over 1 billion years, so the clues are faint and scattered. But scientists have pieced together evidence from ancient mountain belts and the magnetic signatures locked in old rocks to create a picture of this primordial world. Rodinia's existence and eventual breakup may have had a truly profound impact on the planet, potentially triggering some of the most extreme climate events in Earth's history, the snowball Earth periods. The theory goes that the breakup of this massive continent increased rainfall and continental weathering. This process drew massive amounts of carbon dioxide, a greenhouse gas, out of the atmosphere, causing global temperatures to plummet. The result, Earth may have been covered almost entirely in ice, from the poles to the equator, for millions of years. It was in the aftermath of these extreme cold spells, as the planet thawed, that we see the first major explosion of multicellular life in the fossil record. It is a tantalizing idea. The breakup of a forgotten supercontinent might have paved the way for the evolution of all complex life, including us. But of all the supercontinents, one name is probably familiar to everyone: Pangea. It's the classic jigsaw puzzle supercontinent, where you can almost see how the coastlines of Africa and South America fit together. Pangea came into its own around 335 million years ago, bringing together nearly all of Earth's land masses into one colossal continent surrounded by a single global ocean called Panthalassa. Life on Pangea was a world of extremes. The vast interior of this supercontinent would have been an immense, arid desert, subject to scorching summers and frigid winters, a far cry from the more moderate coastal climates. Pangea's formation coincided with one of the most devastating events in the history of life, the Permian-Triassic extinction event, also known as the Great Dying. About 252 million years ago, over 90% of all marine species and 70% of terrestrial life vanished. While the exact cause is debated, many scientists link it to the massive volcanic activity that occurred in what is now Siberia. The formation of a single supercontinent could have contributed to these massive eruptions and the resulting catastrophic climate change. Pangea was the stage upon which dinosaurs first evolved and rose to dominance. But like all supercontinents before it, Pangea was doomed. Starting about 200 million years ago, it began to rift apart, slowly and inexorably separating into the continents we know today. A majestic process that continues to this very moment. So, we've seen the continents come together and break apart. What does the future hold? The dance isn't over. Geologists, by tracking the current movements of the tectonic plates, can project their paths far into the future. And what they see is the eventual formation of the next supercontinent. Some call it Pangea Ultima. In roughly 250 million years, it's predicted that the Atlantic Ocean will close, bringing North and South America crashing back into Africa and Eurasia. Australia will have long since collided with Asia. The result will be a new Pangea, a new giant landmass with a vast, landlocked sea in its center. The world will be utterly transformed once again. Thinking about these future continents really puts our own existence into perspective. The map we know, the world we live in, is just a temporary snapshot in Earth's incredibly long and dynamic history. Our planet is a living, breathing entity, constantly reshaping itself. The ground beneath our feet is not static. It's part of an ancient, cyclical story of creation and separation that will continue for billions of years. The continents are always on the move, engaged in a slow, silent, and powerful dance across the face of the Earth. Thank you so much for joining us on this journey through deep time. If you found this mind-bending, please hit that like button, and be sure to subscribe and ring the bell so you don't miss our next exploration. Until next time, stay curious.